Hello. Let me go over the solution for test one. Test one, you have this frequency table, which we have sort of the weight pound for 100 adult patient is in each class. You have the number of patient in each class, the class midpoint, relative frequency, cumulative frequency, and cumulative relative frequency. So the first question I asked, what proportion of number of patient was admitted 140 to 149? Basically, you're going to go to look at relative frequency, and in that is your proportion 0.12. The second question I asked you, what are admitted between 140 and 169? So that means there are three class you're looking. So you can add up either the number of relative uh, uh, relative frequency 0.12, 0.2, 0.25, which is 0.57, or you can add up the number of patients for this class divided by 100, 12 plus 20 plus 25 divided by 100, you get the same number. And so 0.57 is correct. What class is the highest relative frequency? If you look at the highest is 0.25. What is the lowest one? So that's the correct answer, 160 to 169. What is the lowest frequency table? If you see is 5, 120 to the class interval is 120, 129. And what type of graph would you use to present this data? Your histogram, bar graph, or pie graph. So you can use all of these graph actually, and more, some of other more graph you can use it. So the correct answer was all of the above. The following are 20 patient weight loss, and I ask you to calculate means, median, mode, range, variance, and standard deviation, 25, 75, interquartile, and also I ask you what you need for box plot. So the mean, basically you add up the number, divide the patient, is 11.7. The mode is the most frequent number. If you look at it, there are four of these value. 12 is your mode. And median, first you're going to order all the value you have. So it's the lowest 6 goes to 19, the highest. Because our n is even number, then you have to take the middle order value, 11th and 10th and 11th, which would be 12. So, and the variance and the standard deviation, you use the formula for variance, and when you calculate that, you get to 14.64. The square root of that, 3.83, is your standard deviation. The range is the maximum minus the minimum. 19 minus 6 is 13, your range. Now, finding 25 and 50 and 75 percentile, the minimum we know is 6. You use the MP, 20 times 0.25 is fifth. So basically, because it's round number, you take the fifth and average of fifth and sixth value. So value for fifth and sixth in your order is 8 and 9. The average of those would be 8.5. That is for your 25 percentile. And for 75 percentile, you do the same thing because it's round number. You take the average of that value, 15 and the 16, which is both 14. So 14 is your answer for 75%. Interquartile range is the difference between 75 percentile and 25 percentile, which is 5.5. So that's the correct. And what we need for box whisker plot is 5 value, minimum 25, 50, 75, and maximum value. Question 3 is the probability. So we have a smoking by gender. And the first question I ask you is, if you pick a student at random, what is the probability that this student ever smoke? So you're looking at the column of ever smoke. The total is 300 among 1,000. So 300 divided by 1,000 give you 0.3. What is the probability of a student who male never smoke? So this is the cell probability. So you have male and 400 of them, divide by 1,000, you get 0.4. What is the probability a student ever smoke given was female? So you're looking at here, because it's given is conditional probability. So we're asking if that female, 100 of them, among those female, what is the probability? So 100 over 400 is 0.25. Suppose we pick a student random. What is the probability that a student ever smoke, or being female, or both? So again, this is the situation. You have two events where we are calculating the probability for or. So you call the ever smoke your A, and B would be your being female. So basically you write probability A plus probability B minus probability A minus B. 300 over 1,000 plus 400 over 1,000 minus 100 over 1,000 is 0.6. So basically that smoke and female, that was the intersection, the last term you put in the formula. How many marginal probability do we have for this? Remember, you have two column, two row. So the total of marginal is based on your total of column and row. You don't count the total here, just the category you have. So you have two group, male, female, and two group smoking and never smoking. So the total is 4 marginal probability. So question 4, we have breast cancer and the test result. So I ask you to calculate sensitivity, specificity, false negative, false positive, positive predictive value, negative predictive value for this example. Remember, first thing you want to do, notate your cells. So that will be A, B, C, D. And then from there, using the formula for sensitivity, A over A plus C is 45 over 50.90. Specificity is D over D plus B, which is 440 over 450 is 0.98. Again, for this is your A, this is your B, C, and D. So adding up that would be 450. And then false negative is 1 minus sensitivity, which is 1 minus 0.90 equal 0.1. False positive is 1 minus specificity, 1 minus 0.98 is 0.02. And positive predicted value is A over A plus B, 45 over 55.82. Negative predicted value is D over C plus D, 440 over 445.99. So we are here, you are looking at the row, basically. The total is your positive row and negative is the total for negative row. Question 5, we have a binomial distribution. The P is 0.1 for failing NCLEX, and the number of students is 15. I ask you, find the probability the number of students who fail NCLEX would be 1. So this is like probability X equal 1. So you can use the either the formula, put it in that formula, calculate, or you can use the table. The way you're going to use table, you first find your N15 from binomial table. Then you find 0.1, the probability. Then remember, when you're looking at the 1 here, that value 0.5490 is the cumulative, which means is probability X equal 1 plus probability X equals 0. Therefore, we have to take the probability X equals 0 out of that, so which is the above number, 0.2059. So that's the reason I put 0.5490 minus 0.2059. We got 0.343 as answer. Now, the mean basically is N times P. 15 times 0.1 is your 1.5. The variance is 15 times 0.1 times 1 minus 0.1 is 1.35. That's the correct answer. Question 6, we have a sample information for reducing blood pressure for control intervention. We have 10 for each group. and the reduction of blood pressure for control was 5, and for intervention 10. The sample standard deviation was 4 and 3. I asked you, what is the 95% confidence interval for control? So you're using T because we have sample information. First, you're going to find the T value from table. The T value from table, because is that, again, you're looking at the two side for 0.05, and your sample is Tn, so you take 1. So Tn minus 1 is 10 minus 1 is 9. So, and for 0.05 for 2 tail, you have 2.62. So that's the value I find. That's my reliability coefficient. Then I add 5 is my mean, my standard deviation 4 over square root 10. You simplify, you get 2.14 and 7.86. We would like to know if this data provide us sufficient evidence if the mean of number of units reducing blood pressure for control is greater than intervention. What statistical test you would use? Because our sample, we have information about sample. First of all, you have 2 samples, so you know you have to use 2 samples. Now choosing known variance and unknown variance, because we don't know the sigma or population variance, then you use variance is unknown. 4 is correct answer. Question 7. Here we have 2 sample of men and women asked if they exercise 3 times. 600 men said yes out of 1,000. 550 said yes out of 1,000 women. So I asked you to calculate the proportion for men and women. Basically 600 over 1,000 is 0.6. 550 over 1,000 is 0.55. And then I asked you to calculate the confidence interval for men. So basically, for proportion, you remember you're using the Z value for reliability. 0.975 is 1.96. You put the proportion 0.6 plus minus 1.96 times 0.6 times 1.6 over 1,000 US square root. So you get 0.57 and 0.63. So that's the proportion you get. So, and also that's the correct answer, 0.57 and 0.63. We would like to examine if the proportion of men who exercise more proportion than women, what test you're going to use. We're talking about proportion and 2 samples, so 2 proportion test is correct one. Question 8 is asking about, again, we have a 10 patient depression score. We had baseline and 10 days. So you have the information about the difference and DI squared. What statistical test you use? Because these are dependent, you use 1 per sample t-test. I asked you to calculate t-test. You're using the d bar, and first calculate d bar, which is adding up. You have a negative 82 divided by 10, you get negative 8.2. You calculate the sample standard deviation, which is 80, variance is 80.18. A square root of that gives you 8.98. Then you use the 1 sample t-test, replacing in the formula, you get negative 2.897. So here we are, so that is the correct answer. Can we conclude based on this data, new drug improved alpha 0.01? If you look at the t value for 1 tail, again, here our sample was 10, so it would be 9 and 0.09. So 1 tail, 0.9, and 9 is 2.821. So that's 1 tail test. So since our absolute value 2.897 is greater than that, we reject the null and we said yes, because our absolute value is greater than t value from table. So that is the correct answer. So I hope this feedback helped you to understand better what you were missing in the test.